Hello. If my distinguished colleagues knew this, they would rend me limb from limb. But because my work is devoted entirely to interactive technology, I've convinced the organizers that I have nothing to share with you if you and I are simultaneously machine gunned by slides from a PowerPoint robot. So they let me use Sketchpad instead, and that means we get a bit of interactivity. And if that just dampens the spark of my ignition, I hope I make up for it with explosive ideas. And my ideas are simple in three, and they are that learning is dynamic, the mathematics is dynamic, and the technology is at last dynamic. And the first of those is obvious, but the second is not, because of this myth of sort of the inviolability and the permanence of mathematics. And our curriculum, and more importantly, our technologies shape this myth and create it. And that's why the third point is so important, because it's only within our lifetimes that technology has become sufficiently interactive that it can be as dynamic as our mathematical thinking and our mathematical learning. So the context for my interest in all of this is my work with the geometer Sketchpad, which I've been working on for 20 years. It's sort of the only thing I do. And it's a big program. It's used across mathematics, but it has a simple idea at its core, and it's this idea of dynamic geometry, which says that any mathematical creation you create in the program can be manipulated into any other mathematical configuration that shares the same definitions. So as you begin changing things, your attention is drawn not only to what changes, but to what doesn't change, to invariance as well as variation. And as you look through the whole set of possible differences to generalizations, this triangle is now every possible triangle rather than just an example of a triangle. And so a simple triangle becomes a door to deep mathematical ideas, fundamental mathematical ideas like generality and invariance. Research shows us this happening in classrooms. The time Sketchpad came out, it was a coincident to a major research volume that included a student misconception in the United States at the time. Up through 8th grade, students could generally identify a shape like the one on the left as a triangle, but on average would not identify that shape as a triangle. Now, there's nothing developmentally about needing to be 15 years old to understand a general triangle. In hindsight, this is a problem of technology. Students learn by the examples we give them, and before 1992, no textbook had pages large enough to indulge time in triangles shaped like the one on the right, much less the idea that a triangle like the one on the left could become a triangle like the one on the right. Jump ahead to the Sketchpad era. A study coming out just this year shows that a team of researchers using Sketchpad can systematically dismantle and prevent this misconception in student populations starting in kindergarten. This is a kindergarten quote from that study. Because you can stretch it, every triangle could be a different shape, might be a different shape, but it has to have 3 corners. So there you have a 4th grader making a mathematical justification, a 4-year-old using generalization, invariance, and a focus on definition. Now, this is not just stretching triangles, it's stretching kids' minds. But it's also an example, I think, more than of just dynamic technology changing student thinking. It's also changing fundamental representations we use in mathematics. We didn't used to use triangles like this. And that's an idea that many people in mathematics find more difficult to handle. This is this dominant myth that mathematics is immune to history and to context and to technology. And you've heard it in the case of geometry with this picture, that in the beginning there was the father of geometry, Euclid, and that basically now we teach that, and technology sort of decorates our teaching out at the tail end, but is superfluous. And this is a pretty dispiriting picture of an intellectual history. It's 2 millennia of a flat line, and fortunately it's also a false one. What really happens is that Euclid doesn't introduce the era of geometry, he ends it. One of the most fertile periods of geometric thinking is the 300 years up to Euclid, and we name it after the technologies that produced it, compass and straight edge. And Euclid brings this to an end by changing the technological representation and turning it into a handwritten manuscript. Manuscripts are great from the historical perspective. It's why we can read Euclid today, but they're horrible as interactive technologies. You think you have problems with equity and cost and access with your technology? Imagine your only math book was 300 donkey miles away and was written in ancient Greek and was rotting in a library. That's why this is the Dark Ages, this graph that most people think of as the glorious time of Euclid. And it ends with the next technological revolution. The printed book finally gives us the ability to have conversations, intellectual exchanges that transpire within lifetimes rather than across generations. And in our generation, the digital computer has created more geometric innovation, more geometric scholarship, whole new fields of geometry than have existed in the past 2 millennia, all put together. This is a picture of mathematics profoundly shaped by the technologies we use to represent it. And at each step of the way, there have been the naysayers and the head shakers. They aren't all ninnies. One of the famous math teachers bitterly opposed to the idea of writing any of this down was Plato. But history shows that in the long run, they're wrong. Progress happens. So ignore the technological naysayers and join the progress. If you expose your mathematical learners to these dynamic technologies, you both equip them for a better comprehension of the mathematics of the past, but also give them the tools to create mathematics of the future.